Statistical Approaches and Modeling in Environmental Sciences. Attributes and variables. Types of variables: qualitative categorical, for example, species type or land use type; quantitative numerical, for example, temperature or pH level; scales of measurement, nominal; categories without any order, for example, types of soil; ordinal categories with a meaningful order but no consistent difference between categories, for example, pollution levels, low, medium, high; interval numerical scales with equal intervals but no true 0 point, for example, temperature in Celsius; ratio numerical scales with a true 0 point, for example, rainfall in millimeters. All right, let's dive into the measurement of central tendency and dispersion. So first up, we have central tendency. The mean is the average value. The median is the middle value when the data is ordered. And the mode is the most frequent value. Now, on to dispersion. The range is the difference between the highest and lowest values. Variance measures how much the values differ from the mean. And finally, standard deviation is the square root of the variance, representing the average distance from the mean. Next, we have the standard error. The standard error is the standard deviation of the sampling distribution of a statistic, typically the mean. It measures the accuracy with which a sample represents a population. Moving on to moments. First, we have the measure of skewness, which describes the asymmetry of the distribution. A positive skew has a long tail on the right, while a negative skew has a long tail on the left. Next, the measure of kurtosis describes the tailedness of the distribution. A leptokurtic distribution is more peaked than a normal distribution, whereas a platykurtic distribution is flatter than a normal distribution. All right, let's dive into the basic concept of probability theory. Probability is essentially a measure of the likelihood that an event will occur. It's a fundamental concept in statistics and helps us make sense of the randomness in the world around us. Now, there are some basic rules we need to understand. First, we have the addition rule, which is used when we're interested in the probability of either of two events happening. Then there's the multiplication rule, which comes into play when we want to know the probability of two events happening together. And don't forget about conditional probability, which helps us determine the probability of an event, given that another event has already occurred. Moving on, let's talk about sampling theory. This is the study of relationships between a population and the samples drawn from that population. It's a critical part of statistics because it allows us to make inferences about a larger group based on a smaller subset. There are several techniques we use in sampling theory. Random sampling is where each member of the population has an equal chance of being selected. Stratified sampling involves dividing the population into subgroups and then taking a sample from each subgroup. And finally, systematic sampling, which is done by selecting every nth member of the population. These techniques help ensure that our samples are representative of the population, giving us more reliable and accurate results. Distributions. Normal distribution, symmetrical bell-shaped distribution, for example, heights or test scores. Log normal distribution, a distribution of a variable whose logarithm is normally distributed. Binomial distribution, number of successes in a fixed number of trials, like the number of defective items. Poisson distribution, number of events occurring in a fixed interval of time or space. T-distribution, similar to normal distribution but with heavier tails, used when sample sizes are small. Chi-square, distribution of a sum of the squares of k independent standard normal random variables. F, distribution ratio of two variances used in ANOVA. Correlation and regression. Correlation, measure of the relationship between two variables. Pearson correlation coefficient, RR, measures the linear relationship. Regression predicts the value of a dependent variable based on the value of one or more independent variables. Simple linear regression, one independent variable. Multiple regression, more than one independent variable. Tests of hypothesis. T-test compares the means of two groups. Independent t-test compares means from two independent groups. Paired t-test compares means from the same group at different times. Chi-square test tests for independence or goodness of fit. ANOVA, or analysis of variance, compares means across multiple groups. One-way ANOVA, one independent variable. Two-way ANOVA, two independent variables. Significance and confidence limits. Significance level, alpha probability of rejecting the null hypothesis when it is true, commonly set at 0.05. Confidence interval, range of values that is likely to contain the population parameter, commonly set at 95% confidence level.